All right, here are our solutions to quiz 1 for Math 111. First question says, how far apart are these points right here? There's a few different ways you can answer this question. One way would be to use the distance formula. Distance formula says that the distance between 2 points, x1, y1, and x2, y2, are given by this formula right here. Kind of a mouthful, kind of a mess here, but you can use it. You could say, here's x1, here's x2, or x1, y1, x2, y2, and it'll work. Or you can say, you can kind of talk your way through it. The x's, -2 and 6, are 8 apart. And the y's, let's see, from 2 to -4, it looks like those are 6 apart. So distance, which maybe I'll call it C, is given by, so let me rewrite that. So if I call distance C, so if distance C, I got that 8 squared plus 6 squared has to equal C squared. That is, C squared has to be 100. So C is 10. That's the same answer you should get over here. This will end up being 8. You'll square it, you'll get 64. This will end up being 6. You'll square it, you'll get 36. You'll add those two numbers together, you'll get 100. Square root of 100 is 10. So one way or another, get something like this. Since in class I did it more talking through this way, I worked through this way. But I'm fine with using this formula, whatever you want. Good enough? All right, second one, circles. Give the equation in standard form of this circle. Okay, so to give the equation in standard form, you need to know a few things. That the standard form, how should I write this? How about the standard form of a circle with a radius of r and a center hk. So what I'm saying, h is the x-coordinate of the center, k is the y-coordinate of the center, and the radius is r, is given by this equation, x minus k, x minus h, I guess, if I'm making h the x-coordinate, squared plus y minus k squared is equal to r squared. You know what? I want to switch that up. I think what your book uses is KH as the center. It really makes no difference, but I just don't want to confuse you by using different letters. So let me change it a little bit just so it matches up perfectly with your book. We get this formula here. So in this picture, we have that k is equal to -3. Yeah, the x-coordinate of the vertex here looks like it's -3. And h is equal to 4. That's the y-coordinate of the vertex. And r, how can we figure out what r is? Well, there's a few ways. I think the easiest way is to note that we're tangent to the x-axis down here. So if the center has a height of -4, and all the way down the bottom we get to the height of 0, our radius must be equal to 4. You could also kind of count over 1, 2, 3, 4. It looks like it's about 4. There's probably other ways to do it too. But I think it's easiest just to see that it's 4 that way. So all you got to do is rewrite this thing, but plug in these values. So we get x plus 3 squared plus y minus 4 squared, 4 for this 4, not for this 4, is equal to, you can leave it as 4 squared or 16 or whatever you want, something like this. And just so people don't freak out when they turn in their test, maybe I should even write, you could also say x minus -3 squared y minus 4 squared is equal to 4 squared. You can do something like that too. Whatever. These are all equivalent, however you want to write it. I'm not that picky. Okay, last problem. This one's worth 10 points, so this is kind of half the quiz right here, right? This was only 5, this was only 5. Last one's 10 because it's, I don't know, it's the hardest. It's probably the most important. Find the center and the radius of the circle given by this equation. So we're kind of working backwards. Here we were given the circle and we had to come up with the equation. Here we're given an equation, not standard form, but some sort of an equation. And we want to figure out what the circle is that, that represents. And so the way you do that, or the way I do that, is, hold on one sec, beauty of the pause button. So let's see, I guess we were working on this equation here, and the way I solve these is I kind of group the x's together and the y's together. So what I'm saying is we got an x squared minus 4x, throw those over here, and we got a y squared plus 6y, put those over here, and then the 12, we'll deal with that later. And the basic idea, all we have to do here, maybe I can even take advantage of having different colors here, pretty fancy, is we got to complete the square twice. And what I'm saying by complete the square is, instead of having something like this that has an x squared term and an x term, we want something that looks more like this, just has the letter x written once, and then has this squared out here. And the way you do that is, unfortunately, x squared minus 4x is not a perfect square. There's nothing you can put right here, so that when you square it, you get x squared minus 4x. It's too bad. It would be really nice if there were. If, for example, there was a positive 4 right here, then this becomes a perfect square. But I can't just go throwing a positive 4 over here. I mean, that's going to unbalance things. But as long as I stick the positive 4 over here also, I'm good. Right? I can add 4 to both sides of an equation, but by doing it in this way, I now have a perfect square over here. And kind of the same idea over here. If there just happened to somehow be a plus 9 here, this would work out really nicely. But if I want to put a plus 9 there, I better put a plus 9 over here. So the first step is understanding why I'm able to do that. And then the second step, I guess, is understanding why I chose the numbers 4 and 9 here. Two ways to argue that. I guess the easiest way is half of the coefficient on the x here, half of this negative 4 is negative 2, and negative 2 squared is 4. And that little algorithm will always work. Half of 6 is 3, and 3 squared is 9. That's where those numbers come from. That's one way to remember it. I mean, the way I see it a little bit better is that if you asked me what x minus 2 squared was, I could figure that out. I could FOIL this whole thing out, and what I'd get would be x squared minus 4x plus 4. So I kind of work backwards in my head, do these frequent enough that I can kind of see them. The number that I'm going to put here is half of this, because when I FOIL this out, so maybe this is extra not needed down here, is if I were to FOIL out this x minus 2 squared, I'd say that's x minus 2 times x minus 2. First, outside, inside, last. I get two of these minus 2x's. I get x squared minus 4x plus 4. But because this negative 2x appears twice, from this negative 2 and from this negative 2, this negative 2 right here kind of gets double counted. We end up with negative 4x when we have a negative 2 here. So it's kind of that same idea, but working backwards. If I end up with negative 4x, I must have started with negative 2. Okay, that might have just made it more complicated than it was. If you can figure out how to get to this line one way or another, you're good. There's kind of a plus in between here where I separated these guys. And now over on the right, I have 12 plus 4 plus 9, which is 16 plus 9, which is 25. So what I now have is the standard form of this circle. And you can kind of look at the standard form, and if it helps, you can compare it to this standard form that I have up here and figure out that the center, maybe I can even say, so center is at, I want x minus the x coordinate of the center, so I subtracted 2. So the x coordinate of the center must be 2. And I want y minus the y coordinate of the center, so it must have been y minus negative 3 if I ended up with a plus 3. So the y coordinate of the center is negative 3. And the radius is 5. Why 5? Because 5 squared is 25. And the number that I end up with out here is r squared. This isn't r out here, this is r squared. I want to know what r is. Well, if r squared is 25, r must be 5. You take the square root. One way a lot of people remember this is kind of the opposite of these signs. This is negative 2, so it's positive 2. This is positive 3, so it's negative 3. But that's just a consequence of our standard form here having these two minus signs in there. But the answer is this thing right here. If you get that one way or another, you don't need my long explanation. You're good however you get there, and that's the final answer. Now I guess that's the end of the quiz too.